Hello everyone, this is a walkthrough of Gen 22 Unit 6 solution. Let's take a look at question 1. A student investigates the relationship between length L of a column of air and its temperature theta using the apparatus shown. A sample of air is trapped in the tube between the closed end and drop of concentrated sulfuric acid. Suggest why one end of the tube is left open. So this question is basically a variation of Charles' law, that is the relationship between volume, length and temperature. And do you remember what is it that we had learned in Charles' law? In order to determine the relationship between volume and temperature, the pressure must be kept constant, and therefore to keep the pressure at atmospheric pressure or to keep the pressure constant, that's why it's open to the surrounding, as in open at the top. The student suggested placing the apparatus in a beaker of boiling water and allowing the water to cool. Boiling water is hazardous. Explain one other reason. Okay, so it says boiling water itself is hazardous. So what could be the other reason? Just imagine you are performing the experiment in a lab and you are handling concentrated sulfuric acid. So boiling water could cause the air to expand uncontrollably and cause the sulfuric acid to escape. The capillary tube was attached to a 30 cm ruler and placed in a beaker of water at room temperature. The water was heated gradually and theta was measured using a thermometer. State two techniques that should be used to ensure measurement of theta as accurately as possible. Theta here is measured with a thermometer, and therefore it's imperative that it measures the temperature of water, which is the same as the air column. This is only possible if you ensure uniform heating. So what do we do to ensure uniform heating? We have to start the water to ensure uniform heating. And the other point is the thermometer reading has to be taken by eye. So whenever you take a reading with your eyes, what do? Keep the thermometer close to the capillary tube. The student recorded the following measurements. So these are my measurements. The student predicted that graph of L against theta could be used to estimate a value of theta at absolute zero as shown. So what you're doing is extrapolating the graph to find the value at absolute zero. So discuss whether the student's measurements would lead to an accurate value of theta at absolute zero. So the whole idea of this method of finding theta is through extrapolation. That is, we extend the graph to where there are no data points. For that, we need to plot a best fit line. However, if you look at the plotting points, there are only a very few. So what are the challenges? There are too few readings to draw a best fit graph accurately, which may lead to an inaccurate value of theta. I'll be scrolling through the entire paper. You can pause and take the readings yourself and do it on the paper. And the PDF solution is given in edexcelphysics.com. You can download it from there as well. Just remember, the blue font is what the explanation of the answer is. You don't need to write the text in blue in your answer. The red fonts are your answers, as in the marking points. Okay, so this is something where I have to step in. This is one of the most complicated graphs that has ever appeared in Unit 6 paper. There are two isotopes here, and both isotopes, the graphs for both isotopes will produce a straight line. But You need to appreciate the fact that there are two isotopes here. Since isotope X has a half-life of only 30 minutes, it will decay completely after a few hours. Therefore, you need to calculate the gradient of the second straight section of the graph for isotope Y. Isotope X decays very quickly, so there are two straight line segments in the graph. We have to take readings for the second one because the first one decays very quickly. And how do we figure that out from the graph? So if you look at the graph, you see there are two straight sections. The first one is for isotope X, the second one is for isotope Y. So you have to take the gradient, find the gradient of the second straight section of the graph. For question B, this part is really common and very important. You can see the set of values. All of these are in 3SF. That's why your answer has to be in 3SF. That's a must. So for the second part is the same as taking readings of a stack of paper, or you fold paper several times to find the thickness of one sheet. If you increase the measured value, the uncertainty remains the same, but the percentage uncertainty decreases. For the very last question, they asked about the accuracy, acceptability, or in other words validity. Whenever you are trying to find out whether your answer is valid, always compare percentage difference with percentage uncertainty. And remember, if percentage difference is smaller than the percentage uncertainty, the value is acceptable or valid. Thank you.